Welcome to the Explainer. Today, we're diving into the European Union's rules for animal research, a system designed to tackle one of the toughest ethical knots in all of modern science.
You know, it's this fundamental conflict, isn't it? Our need for medical progress versus our moral duty to protect animals from harm. Well, the EU's answer is this incredibly complex legal framework, and we're going to break down exactly how it's supposed to work.
All right, so here's the plan. We'll start with the ethical compass guiding the science. Then we'll get into the law itself. After that, we'll see who the watchdogs in the lab really are, and we'll wrap up with the big debates that are still shaping the future of all this research. Okay, first up, a compass for science. So what's the moral foundation for all of this? Before you can even write a law, you've got to establish a core ethical principle, right? And really, it all comes down to this one idea. This single clause you see here, it's the bedrock of the entire system. By legally defining animals as sentient beings, creatures that can feel pain and suffer, it forces their welfare to be a top consideration. And this isn't just some nice suggestion. It's a legal mandate across the whole EU. So how do you actually put a mandate like that into practice? Well, the entire system is built around a concept called the 3 Rs. Think of it as a hierarchy of principles, a kind of ethical checklist that every single researcher has to follow. And it's actually deceptively powerful. The first R, and it's the most important one, is replacement. And the law here is crystal clear. If there's a scientifically sound way to get the answer without using a live animal, we're talking computer models, cell cultures, that kind of thing, you must use it. No exceptions. That is the ultimate goal. Okay, but what if replacement just isn't an option yet? Well, that brings us to the second R, reduction. This principle demands that experiments are designed super carefully so that researchers use the absolute minimum number of animals they need to get reliable, statistically valid results. It's all about getting the most information from the fewest lives. And finally, if you can't replace and you've already reduced, there's refinement. For any animal that must be used, this principle says that every single aspect of its life, from its housing and care to the procedures themselves, has to be optimized to cause the least possible suffering. We're talking everything from better pain relief to just less stressful ways of handling them. All right, so those 3 principles, replacement, reduction, and refinement, they're not just guidelines. They're the very heart of the law itself. That brings us to our next section, Directive 2010/63. This is the big one, the legislation that sets all the rules for the entire EU. And the scope of this directive is, well, it's surprisingly broad. It's not just about mice and rats. It applies to all live vertebrates. And that includes things like larval fish and even mammalian fetuses in their last trimester. And in a really interesting sign of the law evolving with science, it also protects live cephalopods. Yep, like octopus and squid, because of all the growing evidence that they can experience pain.
Now, to make sure there's real ethical oversight, every single procedure has to be classified before it even begins, based on how much harm is expected. You can see the scale here. It goes from non-recovery, where an animal is under anesthesia and never wakes up, all the way to severe for procedures that cause significant pain. And believe me, this isn't just some bureaucratic box ticking. It forces a real, deliberate upfront thought process about the potential suffering for every single project.
And there's a hard stop, a non-negotiable limit. The directive draws a very clear ethical line in the sand. Any procedure that's expected to cause severe, long-lasting pain or distress that cannot be effectively managed is flat out prohibited. Period. This is the system's ultimate safeguard against the worst-case scenarios. Okay, so we've got this robust legal framework, but who's actually making sure these rules are followed, inside the labs, day in and day out? That's where the watchdogs come in. Literally, every single institution, doesn't matter if they're breeding, supplying, or using animals for research, is legally required to have something called an animal welfare body, or AWB. You can think of it as an internal ethics committee, a welfare committee, right there on the ground.
And their job is, well, it's extensive. They're there to advise on the day-to-day welfare of the animals, sure, but also on the design of the research itself. They're tasked with making sure the staff are properly trained and competent, with monitoring projects as they go, and with promoting what the law calls a climate of care.
The rule even extends to what happens after a study, advising on things like rehoming schemes.
And this quote from a French case study just nails it. The AWB is meant to be a real service to the organization, not an obstacle. See, when it's working the way it's supposed to, it's a constructive partner. It helps researchers improve their science by improving animal welfare. It's there to make sure that 3Rs are a living, breathing reality in the lab, not just, words on a page.
But of course, this entire system doesn't exist in a vacuum. It operates right in the middle of some intense, ongoing debates. The law provides a framework, for sure, but it doesn't have all the answers. And science and society, they're constantly pushing the boundaries. So why exactly are animals still being used? This chart reveals something pretty crucial. Look at that huge slice of the pie, 72%. That's for basic and translational research, that fundamental quest to just understand how biology works. A much smaller slice is for things like regulatory safety testing. And this tells you that the biggest hurdle for finding alternatives isn't just red tape. It's the sheer difficulty of trying to replicate an entire complex living system to make those foundational discoveries. And that reality, it fuels two fundamentally different worldviews. On one side, you have the legislative and mainstream scientific view. It says, look, the 3Rs are absolutely the goal, but for now, animal use is still necessary to protect human health and develop new drugs. But on the other side, you have many animal rights advocates who argue that animal research is fundamentally unreliable and could be replaced right now if scientists just change their mindset. They're pushing for a total ban. These are really the two poles of the public debate. So where's the hope for bridging this gap? A lot of it lies in what are called new approach methodologies, or NAMs. And this is the really cool cutting-edge stuff. We're talking about 3D organoids that act like mini organs, organ-on-a-chip devices that simulate how our bodies work, and incredibly sophisticated computer models. These are the tools that are slowly but surely making that first R, replacement, a real possibility. And perhaps no area is more ethically charged than the use of non-human primates. Because they're our closest relatives in the animal kingdom, the rules are, as you'd expect, incredibly strict. Their use is only allowed for the most life-threatening or debilitating human conditions, and only when there's absolutely no other alternative species or method that could possibly work. Plus, there's a huge push to source them only from self-sustaining captive-bred colonies. But for all the rules and all the debate, there's one number that really puts the scale of this whole thing into stark perspective. 12.6 million. In just one recent year, that's how many animals were bred for science in the EU, but were killed without ever being used in a procedure. Now, why would that happen? Well, they might just be surplus to requirements, or maybe they were bred for a specific genetic trait that, didn't show up. It's a shocking number, and it's a powerful reminder of the sheer scale of the system. It just makes that second R, reduction, seem more urgent than ever. So, when you look at it all, the EU's framework is one of the most comprehensive in the world. But it's not a static final answer. It's a living, evolving system. And that leaves us with this one big question for the future. As all this new technology, these NAMs, organoids, AI, gets more and more powerful, will it finally draw a clear, bright line between what is a scientific necessity and what is a choice? Or will it just uncover even deeper complexities, making that line harder to find than ever before?